I am Anil Kumar. Welcome to my series on trigonometry. In this video, we'll discuss how to provide solution for trigonometric equations where we are given a restricted domain to work with. At times, we may need to change the domain to get the right answers. Here are 6 examples which we are going to take one by one. First, we'll understand what does change of domain really means in context with a general equation, which is a general transformed equation of sine a sine k x minus p plus q and default domain of 0 to 360 degrees. I'll actually spend some extra time on the very first question, which is very basic, only to understand the concept. Once we have understood the concept, we'll move fast through rest of the 5 questions. Now let's see what do we really mean by change of domain. Now the question here is that in general we are given a function which is a times sine of kx minus p plus q. This is the transformed function, right? And we are also given a domain where x is between 0 to 360 degrees. Now the idea is that if x is between 0 degrees to 360 degrees, then what is the domain of the term which is k times x minus p? We can actually easily change this particular domain and figure this out. So see the process of working with this kind of inequality first. So here we have k times x minus p. So we have to first take away p. So we'll say x minus p. And we'll do this in all the 3 terms. So we have 0 degrees minus p here. And here we'll have 360 degrees minus p. Now we have to multiply by k. So when you multiply by k, we get k times x minus p. And here we get k times 360 degrees minus p. And on the left side, we have minus k times p. So basically, we need to work out all the possible solutions whenever k times x minus p is given to us as an argument within these 2 limits. You get the idea. So that is the kind of domain which we'll say is the transformed domain. For our given question, correct? So that is the concept. Let's take up the first example, and in this case we'll further try to understand this. Here we'll solve sine 2x equals to half within the domain 0 to 360 degrees. Now if I sketch a graph of sine x, then the graph will look something like this, where the values will be from plus 1 to minus 1. Now when I say it is equal to half, it really means that if I draw a line at half, wherever the graph intersects, that should be my solution. Now this is the solution for sine x, not sine 2x. How do we get solution for sine 2x? This is what the question is. So we could think like this, that when I say sine 2x equals to half, I can consider this to be as sine of t, some other thing, equals to half. Now if I consider that as t, then my domain also changes. Now this is not x, it is 2 times x. So what will I do? Well, I'm going to multiply each term by 2. So we get 2x here. And this becomes 720, 2 times 360, correct? And that becomes 0 times 2 still remains 0. So now, strictly speaking, as far as 2x is concerned, my domain has kind of extended to 0 to 720, right? That's what it means. So if I change this to t, that means the value of t should be between 0 to 720, all the values. That's what we mean, right? Okay. Now we know that for sine t equals to half, t could be what? Well, it is a positive value. So we'll say since it is a positive value, it could have two possible solutions. One in quadrant 1 and the other one in quadrant 2. So those are the possible solutions. One in quadrant 1, the other one in quadrant 2. Since we know the cost rule, right? So CAST. Sine is positive in quadrant 1 and 2. Now here the acute angle is what? The acute angle is 30 degrees. You could use the calculator or you could also use special triangles. So if I use a special triangle, then the sides are 1 to square root 3 and that's the angle 30 degrees, for which sine is half. So my related acute angle is 30 degrees. The other solution is 150 degrees, which is 180 minus 30. So I get two solutions from here. One is that t should be equal to 30 degrees and the other is that t should be equal to 150 degrees. But see what has happened. We have extended domain. The domain has changed from 0 to 360 to 0 to 720. Now, the period of sine function is 360. So we could add 360 to this. So if I add 360 to this, I get the next value. So I'm doing plus 360. And also I can add 360 to 150 to get another value. So what do I get? By adding 360 to 30, I get 390, right? And by adding 360 to 150, I get what? 0, 6 and 1, and 3 plus 1 is 4, 510. We are still within the domain from 0 to 720. Now, if I try to add more 360 to it, let's say, I try to add 360, in that case, what do I get? Well, I get 750. 750 is not in my domain because my restriction is that I can only go up to 720. So I'll not take this value. I'll go up to these four values. This does make sense, right? So that is how you can get your initial values of t or 2x, right? So now we can write that 2x is equal to 30 degrees, 150 degrees, 390 degrees, and 510. That is a value of 2 times x. X should be half of these. Dividing by 2, we get our answer, which is 15 degrees, 75 degrees. It goes 1 times 19, 9, and 10, 195. Half of 510, 2 is 4, 5, and 5 degrees. Do you see that? So what we get here is the final solution. So our answer here is that we get four solutions for the given equation, and we can now write down the answer as x is equal to 15 degrees, 75 degrees, 195 degrees, and 255 degrees. Well, that is expected. If you look at it, then you will understand that for sine 2x, if I sketch a graph, let me do a small graph here. There will be two waves between 0 to 360, one and then another one. So between 0 to 360 degrees, I will actually have two sine waves. And at half, I do expect four answers just as I got here. So those are my 4 values. Do you see that? So these 4 values have been written in this fashion. So you could now correlate with your graph also. So horizontally compressed by a factor of 2 will actually give us not 2 but 4 values between 0 to 360 for sine of 2x equals to half. Correct? So I hope these steps are absolutely clear. Let me take another example here, which is also relatively simple, where we'll practice the concept learn. This time, the question for us is cos of half x is equal to half, where x is between minus 360 degrees to positive 360 degrees. So we have changed the domain. Now, if that is the case, what should be the domain for half of x? Well, half of these values. That is to say, from minus 180 degrees to positive 180 degrees. So those are the values in which we should be writing our answers, right, to begin with. Now again, this is also a simple case. We are saying cos of something is half. We can again look into the same 30, 60, 90 triangle where the sides are 1, 2 and square root 3. Cos is half means we are looking at 60 degrees, correct? So that is what we are looking for. Now cos is positive for which values? It is positive in quadrant 1 and in quadrant 4, right? So that is the cos rule. So we have solutions in quadrant 1 and quadrant 4. So we could write plus and minus. Since we have plus and minus, it's a good idea to use plus and minus 60 degrees, right? So we can say that in this particular case, when cos of half x equals to half, we can say half of x is equal to plus 60 or minus 60. Well, that gives us two values, but our domain is from minus 180 to positive 180. We could still add 360 or subtract 360 to get some values. If I try to do that, then what happens? Well, let me try it. So if I add 360, I get a value which is 300. Well, that is not in our domain, right? So it doesn't work. On this side also, I'll get minus 300, so that will not be in our domain. So the only two values are plus and minus 60 degrees, correct? And therefore, those are the values with which we'll actually get our final answer. So if half of x is plus 60 and minus 60, what is the value of x? X will be 2 times these values, so it'd be plus 120 and minus 120 degrees. It's good to write degrees, right? So we have our answer here, and that is x is equals to plus minus 120 degrees. Clear? So that is how we can easily get our solution. So I hope the steps are absolutely clear. Correct? Now let's take the next example, which is based on tangent. So we have here tan of x equals to 3.0, and the value of x is between 90 degrees and 450 degrees. So we have changed the domain altogether. Since we are talking about the same argument, which is x in both the cases, we don't really have to modify the domain. But we have to look for solutions in the given domain, right? Okay. So we can say for tan positive value, that means what? Tan is positive. Let's write down the cos rule in two quadrants, and those two quadrants are quadrant 1 and 3, right? So those are the quadrants. So that line. Remember that the period for tan is 180. right? Okay. So we can actually use the calculator to find this answer. Tan x is this. What is x? X is arctan, or you can say tan inverse of 3.0. Let's use the calculator to find the answer. So we have shift tan inverse of 3. That gives us 71.56. Let's round it to three significant figures, 71.6 degrees. So that becomes our solution. But that is not in the given domain. The domain lowest value is 90, not 71.6. So what should you do? Well, the period is 180. So what we can do here is that we can add 180. So that is what we could do. So that really means we got one solution. The other one is, strictly speaking, 180 plus that. And then we can continue going like this and see what all could fit into this set of domain values. Correct? So let's try it out. So we have 71.6. We'll add 180 to it. Correct? So when you add 180, what do you get? So we have 71.6 and we are adding 180 to it, and we get 251.6. Well, 251.6 is within the domain, right? It is within the domain. So that is correct. Now we can again add 180 to it. So what we get? So we'll add 180 to it, so plus 180, and that gives you 431.6. So that is also within our domain, right? So we get two answers here, and therefore we can now write down our answer, and that is x is equal to 251.6 degrees and 431.6 degrees. You see how we got both the values within the given domain. Correct? So, well, this was the domain was within a period of 2 cycles of tan. So we got two answers, and that is it. So we can now write down that the answer is that x is equals to 251.6 or 431.6. That is to the 10th of place. Now let's look into the next example, which is question number 4. Now here is question number 4 for us. Sine of 100 minus x equals to 0.4567, where x is between 600 degrees to 960 degrees. So the domain has been shifted. I would like you to pause the video at this stage, solve the question, and then look into my suggestions. So let's try to solve this. We have the question as sine of 100 minus x equals to 0.4567, where x is now between 600 degrees to 960 degrees. First step is to figure out what should be the domain for 100 minus x. So let's work on this. So minus x should be, we interchange the signs, right? So whenever you're doing negative, the inequality sign also changes. So we get this, it makes sense, minus 600. And now we have to add 100. So we get 100 minus x should be, adding 100 to this will really means that be minus 860 degrees, and this will be minus 500 degrees. Correct? So we need to really get our values within this particular interval for 100 minus x. Does make sense to you? Correct? So that is the first step. The second step is to look into the sine function. We want to have the positive value. So start with the cast rule. Sine is positive, means we are working in quadrant 1 and in quadrant 2. So we are expecting two answers, one in quadrant 1. the other one in quadrant 2. So let's find the acute angle alpha first, and then we will see the rest. So let's find the acute angle alpha first. So we are saying sine of alpha is equal to 0.4567. So alpha will be sine inverse of 0.4567, and this value is, let's use the calculator. So we have shift sine inverse of 0.4567, and that gives me 27.174, which I'm rounding to 27.2. So that is the value of alpha. So that is one angle which we get, and in quadrant 2 it will be 180 minus this, right? So the other one will be 180 minus 27.2 degrees, and that is how much? So that is 180 minus 27.2 degrees, and that is 152.8. So we have these two angles to begin with. So that becomes the starting point for us. But clearly, as you can see, these two numbers are not within the domain. That means we have to add multiples, right? So we have to add the multiples of 360 degrees to get our correct domain, right? So we have to add multiples of 360 degrees. So clearly, to get into this, these multiples should be negative, right? So we have to actually take away multiples of 360 to get into this particular domain. So when you do this exercise, it becomes absolutely clear that for 27.2, we should take away 720, right? And also for 152.8, we should take away 722 cycles. Then we can get to this particular domain of minus 500 to minus 860. So let's do it. So if I take away 720, what do we get? Here we get minus 567.2, and on the other side we have 27.2, and we are taking away 720. We get minus 692.8, right? So those two values which we get are actually within the expected domain. Do you see that? So they actually fall somewhere in between. So minus this and right. So they are somewhere in between. So it works. And therefore, we can now say that 100 minus x could be equal to minus 692.8 degrees or minus 567.2 degrees. Does make sense to you? So we need to now work on this. We have minus x equals to, we'll take away 100. So we get minus 792.8 degrees minus 667.2 degrees. And x will be, change the sign, 792.8 degrees or 667.2 degrees. You can clearly see that this answer is within the required domain. Correct? So that is how we are going to answer it. So I hope the steps are absolutely clear. So you have to add or subtract the multiples of 360 to get to the required domain. Let's take the next example now, which is 3 times sine 3x equals to 5 times cos 3x, and x values between minus 340 to 20 degrees. So the equation is 3 times sine 3x equals to 5 times cos 3x. So we can divide by cos 3x, you can say cross multiply, and here we get 5 over 3. So that is tan 3x equals to 5 over 3. Now we have 3x here. As far as the domain is concerned, we are talking about x. So what should be 3x? So let's multiply by 3x and figure out what numbers should we be working with. 3 times 20 is 60 degrees, and 3 times minus 340, so 3 times 0, 0. 3 times 4, 12, 2, 1, 9 and 1, 10. So minus 10, 20 degrees. So for 3x, we are looking into 10, 20 to 60 degrees. That is the domain for us, right? Okay. Now for tan, the period is 180 degrees. So 180 degrees is period of tan x. Remember that part. Okay. Now let's find the acute angle. So what should be the acute angle? So in this particular case, let me work out here itself. For tan, it is positive in quadrant 1 and 3. So you can write down the cast rule to be very sure about it. And you know that is the position. So we are trying to find the angle alpha first, and then we are going to add or subtract 180 degrees, right? So let's say tan alpha, so alpha equals to tan inverse of 5 over 3. So we'll use the calculator to find this value. Shift tan inverse 5 divided by 3 bracket close is equal to 59.03. So we get this value as 59, let's say 59 degrees. So 1 less than 60. But definitely 59 degrees is less than 60 degrees. So we cannot take that as one of our answers, correct? So what we need to do? Uh, yeah, we can take, this is from, that is the upper limit. So 59 is one of the answers, correct? So that will work for us. It is less than 60, that's what we want. Higher end is 60. So that works. Okay. So we have one solution as 59 degrees. So we are writing 3x as equal to 59 is correct. Now the others, we can keep on taking away. We'll do minus 180 this time and then get all the other answers. So let's do minus 180 in 59. So for tan, it is much simpler. Just one value to work with. So 59 minus 180 will give us minus 121, all in degrees. Again minus 180. So keep on doing that. Minus 301. Again minus 180. Minus 481. Again minus 180. Minus 661. So let me write down here. Minus 661. Minus 180. Minus 841. Minus 180. Minus 1021. So when you reach minus 1021, you've gone beyond, right? So that is not the right one. So we have got 1, 2, 3, 4, 5, 6 as expected, 6 answers. So that is 3x. So what is x equals to? So we are going to divide all of them by 3 to get our answer, right? So we get 59 divided by 3, which gives us 19.66. So we'll write 19.7 degrees. Correct? Next one, 121 divided by 3 will give us 40.33. So write minus 40.3. Similarly, minus 301. So 301 divided by 3 will give us minus 1.0 degrees. So we get minus 481 divided by 3. The next answer is 160. And 661 divided by 3. 220.3. 841 divided by 3, 280.3, right? We did one mistake here. Let me rewrite this. 301 divided by 3, 100.3. Correct? So you get all the 6 answers as shown here. Well, some of you could have also done one thing, and that is, we know the period for 3x will be 180 divided by 3. That is minus 60 each time. So you could also do like this, that you could do, I'm writing it in a different thing so that you understand that could be an alternate way. So first one was 19.7. So you can keep taking away from this itself n times 60, because that is the period of 3x. Right? For x, the period was 180, and for 3x, 1/3 of that, 60. So you'll find that all these numbers are with a difference of 60. Do you see that? Does it make sense to you? So you could do that also. But the one method which I'm following is standard and should be used. So that is what you should be doing it. Correct? So those are the 6 answers. Let's take the last example now, which is sine of 90 degrees minus 2 theta equals to half, 0.5, where theta is between 0 to 360 degrees. I'd like you to pause the video, apply the methods learned, and then check with my solution. So again, the question here is sine of 90 minus 2 theta, right, equals to half or 0.5, where theta is between 0 degrees to 360. So first thing is work on the domain. So in the domain, we have minus 2 theta. So what should we do? We should actually factor minus 2 out. And then we get theta minus, dividing 90, we get 45 by 2, correct? Equals to half. Does it make sense to you? So that is how we should be doing, and then you can easily change your domain. So this was a very, very critical step. Now let's see. So we have to first take away 45, so it becomes theta minus 45 degrees. So when you take away 45 degrees, what do you get? So it will be 360 minus 45, that is 315, minus 45 degrees. Now in this exercise, the calculator is allowed, and therefore use calculator, okay? And then we have to multiply by minus 2. So when I multiply by minus 2, I have to interchange the signs. So interchange the signs. And then you multiply by minus 2, so it becomes negative here, right? So negative 630. And here negative becomes positive 90 degrees. So you are expecting the argument to be between 90 to minus 630. Is that clear to you? And then we have sine as positive half. Positive half really means that we are looking for two solutions within quadrant 1 and quadrant 2. Again, you could always write the cast rule here, right? So that you are double sure. We need to now find the acute angle alpha for half. And as you know, we have a special triangle which takes care of this. So there's no harm in sketching it. In your test paper, you should always have these special triangles in your mind. You can always use the calculator also. For sine to be half, we're looking at 30 degrees, right? So we know in this case that alpha is 30 degrees. So the other principal angle is 150 degrees. However, we're looking for from 90 to minus 360. 90 is the upper end, right? So 30 and 150 will work for us, no problems. Another thing is that within this interval, since we have 2 here, there are 2 sine waves, we expect how much? We expect 4 solutions. So I should write down here. So we expect 4 solutions. So at this stage, you should be very clear about what are you expecting. That helps. So we do get 2 values which we can start with. So we can say, well, we do have 2 values, which is minus 2 times theta minus 45 degrees should be equal to, so these are within our domain. So we are saying 30 degrees and 150 degrees. We are going to add 360 to them. So when I add 360 to this, it becomes 390 degrees. And when I add 360 to 150, then it becomes 6, 6 and 5, 11, and becomes 510 degrees, correct? So what we did here was, to these values, we added 360 to get the next cycle. Perfect? Now, that is minus 2 theta minus 45. We need to find theta. First, we'll divide by minus 2. So we get this as theta minus 45 degrees is equal to half of these values, which is 15 degrees, 75 degrees, 195, 255. Correct? So 4, 10, 5, and 10, 20, 55. Correct. So we'll add 45 to it now. So adding 45 will give you what? 5 and 5, 10, 60 degrees. So 45, 10, 5 and 120 degrees. So adding 45, 10, 4, 140. So 5 and 5, 10, 4 and 5, 13, and 114, 240 degrees. And again adding 45, we get 0, 5 and 5, 10, 300 degrees. So those are the 3 answers for us, correct? So we can write down our answers, which are theta will be equal to these 3 values. Is that clear to you? So that is how we could actually answer our question. So that was a very useful information for you, I think. So whenever you have change in domain, work out the actual domain in which you could be writing the values and then solve it as we did, right? So write those values and then isolate theta. So that is the steps required. So that becomes kind of a final type of a question which you can get on this particular topic. So I hope you understand and appreciate that beginning from simple example like sine 2x and ending here at sine of 90 minus 2 theta, we have gone through all the processes of learning how to solve trigonometric equations when we are looking into change of domain. So in this particular exercise, we began with 0 to 360 degrees, minus 360 to plus 360, 90 to 450, 600 to 960, minus 340 to 20, and then again 0 to 360, but we changed the argument considerably. So I hope with that combination you are well prepared for your own test. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.